number A says, I give you probability A, I give you probability B, I give you the and, then I want the probability of not A and B. Now you can go do lots of stuff, but I said to you, if you can use a Venn diagram, it helps you, right? So if I had to go show that on a Venn diagram without being told, then it would mean, why would I intersect them? Because it says there's an A. So there is an intersection, so they are not mutually exclusive. So I'll have A and I'll have B and I'll have a
Sample space.
sample space, which is
1.
because now this is all about, it's not specific things that I'm putting in there, it's all probability, so all the probabilities must add up to 1. Now if I know the probability of A is 0.45 and B is 0.35, that means I can't add them together and say that's what's left is on the outside. You must know that something in the middle there has to overlap each other. Now, I don't have to look very far because they gave me the overlapping. If they didn't, X is your friend. They didn't give me the end, I would have put the end and in there. So now, if I know that that is 0.15, how much is this? 3 and 0.2, because it does give me 0.35 and 0.45. And that's it. No, I'm short. What's outside is 0.35, because I add all of those up, not twice, once, and I'm short 0.35 to get to 1. So the question was, what is the probability of not A and B? Because if you do it this way with a Venn diagram, I just need an answer, but you need to know what to look for. So you're looking, remember I showed you with my hands, where's the not A? And then the and means it has to intersect with B. So where's the not A? Not A. But B?
0.2.
Where did I go both times? 0.2. Finished. Sum is done. Are there alternative ways of doing these sums? For sure. But the Venn diagram is actually a nice go-to. Look again. You look at probability of not A, you look at probability of B, but and means you must let those two overlap, intersect. So where's not A? Where's B? Where did I put my hands twice? 0.2. Done. How many marks was such a sum?
1.
No. Well, the sum was very easy here, but if you did it with Venn diagrams, this would be worth marks because this was a technique. If you did it with formulas, it would be a technique as well. So if you did it with a Venn diagram, it would be worth like 2-3 marks for that, and then for your answer. So it would be like about 4 marks. All right. Now we're not going to do everything on 3 different ways, okay?
Yes.
Next one, they're giving me probability of X and Y, and we're giving you the or, and we're asking you for X and not Y. And what. Do you agree? Venn diagram, let's hope it works. So if we have a Venn diagram for X and Y, are we going to have them intersect? How do I know?
Because
Remember that or, if they didn't intersect, let's quickly do it this way, if they didn't intersect, what would A or B or X or Y then indicate? Then you take the X and you Y and you just add them together for or. Now, does that add up to that? What does that mean? There has to be an overlap. Are you with me?
Yes, ma'am.
If it was just a normal or like this, then those add up to 0.6 and they don't. So I know that they have to intersect, overlap. Sample space, 1 again. So now I know X has to be 0.4, but Y has to be 0.5. Now the or part tells me what? Just what we said now. If you add them all together, you must get 0.6. But I don't know this or this or this. So where's a good technique then? Make it X. X is your friend. Then if this is X, what's this?
0.5
And 0.5?
minus X.
Now where does the all part come in there?
Equals to 0.
That's where you say 0.4 minus X plus the X plus the 0,5 minus x will give you
0.6.
0,6. And then you can solve for x. Definitely, for sure, not the only way. Are you with me? So, adding them all together must give me 0,6 because you know in Venn diagrams all mean add them all together. So now this falls away, that's 0,9 minus x. If I'm correct. So x is 0,3. And that's definitely worth marks, not just only for giving me answers here. So then I'll take my color pen and I'll go back to my Venn diagram and say, okay, now that I have established that x is 0,3, oopsie, x is 0,3, that would make this 0,1. Now we can ignore the blank. And 0,3, this will be 0,2. And now I can also, couldn't I at the start have said, if the OR is 0,6, what's outside? 0,4. Are you with me here? Without first doing that, you could have said, if the OR part is 0,6, then outside should be 0,4. Are you with me here?
Yes.
Alright? So now that I have it, I can answer any questions. The P, X, or not Y. What do I do with or?
You add them.
Put them all together. All my hands and fingers that I'm going to show now, add it together. Where is P, X? Where is the not Y?
0.1 and 0.4.
Not where they intersect, everything. This is the X. This is the not Y. So you've got that and that and that you must add. Can they overlap each other, those OR parts? Yeah, because OR does have intersections, it's fine. So X is 0,1 and 0,3. But then also not Y. Where is not Y?
0.1.
But that was not Y, but or means it can either be in X or not in Y. So it doesn't matter that that's not Y. It's part of the X part. This is part of the not Y. So I have to add
0.4.
So I don't add this twice because it was in X and it was in not Y. So I don't add it twice. And that gives me
0.8.
And if you did, okay, I was going to say if you did add it would have been more than one. It wasn't by accident, it wasn't. But maybe you added too many things and this became 1,1. Then you should have known something's not like that. Because it can't be more than 1. Alright, so a Venn diagram, just the answer. Because you could have just given me the answer, but do you think it's a good idea to show me where you got your stuff from?
Yes.
If your Venn diagram was wrong and you had 0,2 here and 0, what, then I can see, okay, well, you had to do those three. Yours is a 0,2 and a 0,5 and a 0, I don't know what, and that's what you added. I can give you marks for that because you got the right stuff. It's wrong on the Venn diagram, but it's the right stuff that you added together. Okay, last thing. Are X and Y independent? Do you see it in a Venn diagram that they're independent? What is the rule for independence?
X and Y should give you the product of P.
Left hand side and
Right hand side.
the right hand side must then be the product of the two. Okay, so where's the and? We worked very hard in our Venn diagram to know that the and part was 0,3. If this is now exactly 0,3, then they are independent. If it's not, they are not independent. Excellent, you're doing very well. So P of X was 0,4. P of Y was right at the beginning. And the answer is? Which means what?
They are not independent.
I don't have to rewrite the whole identity there for them. But because it's not the same, X and Y are not independent. Because they will always say, are they? First thing. And then why. So you're saying that they're not, and you're giving this is your reasoning with your calculations, because I'm seeing that formula being worked with. Okay. You have to represent the following in a Venn diagram. It says, the survey is done at technological services that teenagers own. 150 teenagers were surveyed and the following results were obtained. So what's that? That's your sample space. 150. So now it's not probabilities, it's actual number of people. Am I going to write Piet and Jan and Kosi and Lebelgang and everybody's name in here? No, we're going to say so many of them. Okay. So many own cell phones, so many own tablets, so many own laptops. Please read through your whole sum, because very often, after giving you all the information, they say, let C be for cell phones, L be for laptops, and T be for tablets. But they could have said A and B and C, and then you've done L and C and T all the time, and then you oh, no, I've done it wrong. Please read the whole thing. They never said anything here. So the logical thing would be to say, they have cell phones, they have tablets, and they have laptops, and there is no correct one. The L could have been here, the C could have been there, whichever way, right? They say 125 of them own cell phones. What does it mean? If you can think back of last year, where does the 125 go? Yes, excellent, over there, because you don't know which of them also has a tablet, also has a whatever. Even be over here. So that's where I put the 125. 47 own tablets. Again, I don't know which goes where. And 58 own laptops. If you add them all together, you're going to say, no, man, this is wrong. That's way more than 125 because there's intersections. 40 own cell phones and tablets. Does that mean that they don't have a laptop?
Yes.
40 own cell phones and tablets. Could they not be cell phones and tablets also there? Yeah? Because they never said, but not a laptop. If they don't indicate, you don't assume. So that's where I taught you, and somebody must have taught you, this will now be the 40 that own cell phones and tablets. 50 own laptops and cell phones. Laptops and cell phones is this part here. 50. That means together 50. 35 own tablets and laptops. So that would be 35 over there. 30 own cell phones and laptops and tablets. Oh, thank goodness there's something I can put in there. That's the only thing. But now I want you to go home and go complete this for me. Because that's all information that there is.
Thank you.
The information, the rest of it now means if this is 40, 10, 20, 5. And once you got them, they must add up to 47. Once you got them, okay, and over here, same thing. And will there be somebody that doesn't have anything shown?
Yes.
So they'll be at the back. All that you have to do for tomorrow.